Here's how to determine areas for VCE methods in less than a minute. What we have here is y is equal to sine of x, and we're trying to evaluate the area in between sine of x and the x-axis for the first cycle. So we can see from 0 to pi, we have an area that's bound above the x-axis, and from pi to 2 pi, we have an area that's actually bound below the x-axis. And how you calculate these areas is actually slightly different. So let's go through the example now. I split it up into two areas. I have A1 up here, A2 down there. Now, A1 is very simple because it's above the x-axis. What we do is we just integrate our function from the lower bound, which is 0, to our upper bound, which is pi. So we go from 0 to pi of our function, sine of x dx. Now, whenever you find a definite integral of a function, it's always finding the area that's bound by that function and the x-axis. Okay, so it's always going to represent that area there. Now, if we go ahead and evaluate this, what we do is we just find the integral of sine of x, which is negative cos of x, and we substitute our bounds 0 to pi. So we'll go negative cos of x minus negative cos of 0. So negative cos of pi minus negative cos of 0. Now cos of pi is negative 1 because if you look at the unit circle, pi is there, which means x represents cos on a unit circle, so it's going to have an x value of negative 1. So this is actually negative 1 here. Now cos of 0 is 1. So this whole bracket here becomes negative 1. So we have negative of negative 1, which becomes positive 1. It's a bit confusing. And then minus negative 1. So that'll be double negative. So 1 plus 1 is equal to 2 units squared. Perfect. Now we have to go ahead and evaluate the second area. Now A2 is actually below the x-axis, so it's slightly different. A lot of people forget this. But what we actually have to do is same thing, lower bound to upper bound. So from pi to 2 pi. Except we actually have to take the negative of it. Now, the reason why we take the negative is pretty obvious, is because it's below the x-axis. So if you don't, you're just going to get the negative area. But it's really important to split up the calculation anyway, and I'll show you why in a bit. So we just do this, sine of x dx, and we go ahead and evaluate this. Now, if we evaluate this, we're just going to get 2 again because of symmetry, because sine of x is symmetrical. This shape is the same as this shape, so you're going to get the same shape on both the top and the bottom of the x-axis. So if we want to find our total area, our A total is just equal to 4 because you just add your two areas together. Now, the reason why I said you still have to split it up is because if you just take the integral from 0 to 2 pi, what's going to happen is that you're actually going to get 0 as your final answer. So if we take integral of 0 to 2 pi of sine of x, what happens is we get negative cos of x, and we have to substitute in 0 and 2 pi. But what actually happens is when you substitute in 0 and you substitute in 2 pi, you actually get the same result. So what's going to happen is you're just going to get something minus the same thing, cancel out to 0, and the reason why it cancels out to 0 is because your positive area cancels out with your negative area. So even if you use symmetry, you still have to split this up and treat each area according to what its position is relative to the x-axis.